Welcome to the BioWhisperer channel. Our topic today is on a perspective overview of carbon-neutral biofuels. So let's discuss in this short video an introductory perspective. Methane, hydrogen, bioethanol, biobutanol, and fatty acid derivatives are attractive renewable biofuels and can be produced by energy microbes such as methanogens, brewer's yeasts, Clostridia, oleaginous yeasts, and some algae in a very low-carbon manner. Unfortunately, the performance of energy microbes, including substrate utilization capacity, product synthesis efficiency, and tolerance to inhibitors and products, are still the putative bottlenecks on the path to industrial production and commercialization. Synthetic biology is an emerging revolutionary technology that offers many approaches and resources to improve strain performance. This is a screen grab from the United Nations program that highlights and actions taken by organizations recognized under its Global Climate Action Award. We all have a part to play. Current research aims to address adapting microbial technology and integrating synthetic biology to help achieve the low to no carbon goals. The recent breakthroughs of synthetic biotechnology in genome editing tools and the acquisition and analysis of extensive omics data have made it possible to recruit genetic elements across species and redesign chassis cells at the molecular level. Accordingly, metabolic pathways or functional modules could be restructured, debugged, and applied in classical and even some non-model strains. More importantly, the synthetic microbial community learning from natural symbiosis phenomena holds great promise for biorefinery and syngas biofixation through the division of metabolic labor and construction of cross-species metabolic pathways. So let us quickly review the concepts of biofuels and how carbon neutrality works as a concept. Carbon neutral or no net emissions of carbon is gaining traction amongst businesses who practice sustainability strategies in their operations to do their bit for the environment. In fact, this movement aims to move progressively towards carbon neutrality, and getting more entities and partners on board the concept will help achieve the said goals faster. Areas of interest includes new engineering strategies for the production of methane, bioethanol, biobutanol, or fatty acid derivatives, which includes alcohol, ester, and alkane. New engineering strategies for biofixation of carbon dioxide or syngas towards the production of added value molecules, as well as new engineering strategies for construction and regulation of synthetic consortium aiming at solving problems raised by monoculture are also areas of interest. In the past 2 years, the COVID epidemic has severely affected global crude oil production and transportation. On the other hand, economic recovery in some countries has further increased the demand for crude oil. Together, these factors have led to a gradual increase in crude oil prices. In addition, carbon emissions have gradually tightened with the enactment of many countries' policies to combat climate change. Therefore, cheap, renewable, and carbon-neutral fuels are receiving more and more attention. To achieve the goal of the Paris Agreement, the world is likely to have to stop adding to the stock of greenhouse gases in the atmosphere progressively. New energy system will include renewable electricity, biofuels and hydrogen, alongside oil and gas will help contribute to the state known as net zero emissions. Synthetic biology offers great potential in tackling the energy challenge, but there are hurdles involved. For instance, what is limiting the deployment of industrial biotechnologies is the high capital cost of constructing the bioprocessing plant. Issues such as avoiding contamination in industrial bioprocesses are also important to address. As we move towards the aim of carbon neutrality, shown here are some research articles performed that utilizes the bacterial system to produce butanol, a carbon-neutral biofuel which can be used to power vehicles. Amazingly, it needs only 3 source ingredients: carbon dioxide gas, solar panel-generated electricity, and light. Since the early 1970s, scientists have been on a quest to develop a technology that could create liquid fuels out of carbon dioxide, water, and sunlight far more efficiently than photosynthesis, the process by which plants harness sunlight to produce carbohydrates and store energy. They call it the artificial leaf, which is a silicon-based device that uses solar energy to split hydrogen and oxygen in water, thereby producing hydrogen energy in a clean way, leaving virtually no pollutants. The technology, which was designed to simulate the natural energy-generating process of photosynthesis used by plants, was first successfully developed by American chemist Daniel G. Nocera and colleagues. Widespread use and industrial scaling up remains challenging. Carbon-neutral bioprocesses are of imminent concern and can be coupled by using integrated bioprocess and biofuel production systems. The integration of bioprocess systems and the coupling between different biofuel generations under carbon neutrality is analyzed and presented to be of great interest for industry and science. Value-added production, that is the recombinant proteins, can be coupled to carbon-neutral integrated biofuel production systems and, hence, integration of different biofuel generations within a biorefinery concept could be translated into a reality. It is also expected that interagency discussions going forward will address land use and sustainability issues, debates food security, second generation and advanced biofuels, voluntary certification and traceability within supply chains. See you in our next video. I would thank you for helping to share your love for this science channel by clicking the like button and subscribe for future updates. If you like this video, please smash the like button and subscribe to this channel for future updates.